morning, grade 11s. We are still busy with trigonometry. Today we're going to combine trigonometry with algebra. But let's just go back to our rules that we know up to now. In the first place, we look at a right-angled triangle. And there we have learned that we have sine theta, which is opposite over hypotenuse. We have cosine theta, which is adjacent over hypotenuse, and you have tan theta, which is opposite over adjacent, SOHCAHTOA, to remember. Then which method? Top times, bottom divide, and to find the angles, it's always the second function. Then we worked with any triangle, not a right angle triangle. There you can use the sine rule, which says A over sine A is equal to B over sine B. We use this when we have opposite sides and opposite angles. The next one is the cosine rule. The cosine rule is to find the third side. You want to find the third side. And then it is b squared plus c squared minus 2bc cosine A. Again, the angle and that side correlates. Then we also have finding the angle when you have three sides. And this is then this formula, b squared plus c squared minus a squared over 2bc. Again, the side, you subtract the side which is opposite the angle, the wanted angle. And the last one is then the area formula, which says half BC sine A. Okay, so now we're looking at try now 42 on page 488. You have a right angle triangle there. This one is x plus 4. Actually, this side there is y. Now, it starts there by saying the area of the triangle. So that is what you should work with. Remember, you have to show that. You may not use that. You must show that. So I know this is a right angle triangle. So I now know area is half base height. So 48 that was given is then a half of x times x plus 4. That's where you're going to start. I will get rid of this fraction here, LCM, so it is then 96, and I'm going to multiply this in here, so then I have x squared plus 4x. Look there, they're on the left-hand side, so you have to bring them over. Negative x squared, negative 4x, plus 96 is equal to 0, and then we have to show that we're dividing this by negative 1. You can either do it like this, or you can write here divide by negative 1, and then we have x squared plus 4x minus 96, which is equal to 0. So that's then number A1. This is then A1. Then they say solve this equation. And we're going to solve this with factorization. So it is x and x, which factors of 96, if you subtract it, will give you 4. And it is 8 and 12. Signs differ. The biggest combination, this one is positive and this one is negative. So x is equal to 8 or x is equal to negative 12. X is equal to 8 or x is equal to negative 12. And then now at number 3, we have to find AB, this side. We choose this one. This is the correct answer. And plus 4, so the answer would be 12 centimeters. 12 centimeters. Right, now we're looking at number B. Number B says tan y is equal to 1 over 6, and we have to calculate the value, find the value of y. We have to find that y first. So this is going to be second function, y, 1 over 6. So second function, tan 1 over 6 is equal to 9.46. So the angle is 9.46 there. And then they say when the length of AC is 9, so this is now the hypotenuse, this one is now 9. And then show that you can get that. And now I'm going to use Pythagoras this time here. So I'm going to say now that x squared, sorry, we're going to use Pythagoras, plus x plus 4 squared, I'm using Pythagoras, is equal to 9. So the square root of this is equal to 9. So to get rid of this square root, I'm going to square. So then you still have x squared plus x plus 4 squared is equal to 81. To get rid of the square root on that side. Now I'm going to solve it here. Remember, this means x plus 4 times x plus 4. Don't leave that step out. Then you're going to make mistakes. So it's x squared plus 8x plus 16, which is equal to 81. And now we can just bring that one over here. I have 2x squared plus 8x plus 16 minus 81. 16 minus 81 is equal to 65. Negative 65. And at number 2, they say now again, solve this equation. And look what they say there. Show your working, give your answer to 2 decimal places, which means that this is going to be with a formula. I hope you can still remember what we were doing. So x is equal to, what was the formula? Negative b plus or minus b squared minus 4ac over 2a. So look how they combine the algebra with trigonometry. This is what we're looking at specifically today. So if I substitute now, it is negative 8 plus or minus negative 8 squared minus 4 times 2 times negative 65 over 2 times 2. So we do this with a formula. The next step is then negative 8 plus or minus, and we have to find the value there in the root. You have to find that value in the root. So it is then 64 plus 4 times 2 times 65. And I have 584 here in the root. Make sure that you get that right. And then we get the 2 answers from there. And x is equal to 4.04. Or x is equal to, we're still finding x here, negative 8.04. And again, obviously, we're going to choose this one, 4.04. Yet they just asked you to solve it. So now in the next step, we're going to use this value because this is the positive value that we want there. They asked the perimeter here. So now it is x plus 4, which was now 12 plus 4, and plus the 4.04. And the final answer is then 21.8. 21.8 that you have there. Right, the next one is try now 43. Try now 43. So here we combine the they combine here the bearings here with a, so this is also a very nice question that we have here. This angle is 40 degrees, there's a 95-degree angle, 12, 10, 30, and 17. And the first thing that we always look, is it a right angled triangle or not? And this is not a right angled triangle that you have here now. So we start off with A. Calculate angle CAD. Angle CAD, this one. So we can use the sine function because you have opposite sides and opposite angles there. We want to find the angle. So sine A, and this is opposite the 10, is equal to sine 95 over 12. Can you see? Opposite sides, opposite angles. That is what we're going to use there to calculate that one. You want to find the angle, so it will be second function, your answer. And I got 56.1 degrees. It's necessary that you first do the exercises and then mark them. Right, then B. Now we want to find BC. So this is this length that we need to find here. This is not a right angle triangle. So I'm going 1/3 side. So I'm going to use the cosine rule. So it is 17 squared plus 12 squared minus in brackets 2 times 17 times 12 cosine 30 degrees. Cosine 30 degrees. And I got that BC, remember it's not BC squared now anymore, is 8.93 meters. Now we're looking at number C. Find the bearings, and this is specifically what we want to look at now here when they have those bearings also there. B from A. Now B from A is this one that we want to find there. So we've got that 40, we have this 56.1, and this one is 30, so we can just add those three angles there, and I have 126 degrees. Remember, bearings are not to decimal places, they are three-figure bearings, so you have to give it like that, as a three-figure bearing. Then the second one is A from B. Now A from B means this is what I want. I'll have to draw a north line there and north clockwise. That is what I want to find out then there. So this one is then 180 degrees, that straight line there, plus the 126.1, because remember, those angles are alternating. This is the unrounded one that I use here, but my bearing is 306 degrees. And then number D, now we have to find angle ACB. ACB, this is now what we want. They say it is an obtuse angle also there. And what we actually have to calculate is BCD. BCD. So this is what we want eventually. So ACB is 72.14 degrees. I calculated in that triangle then there. If it is obtuse, it is 180 minus that one, which makes it 107.9 degrees. Can you see? Remember cos that we worked with. And then ACD is then 180 minus 95 minus that 56.1 degrees. So that one is 28.9 degrees, ACD. And then we come to BCD. As you can see, it's quite a long one, and it's that 107.9 degrees, that obtuse angle there, plus this 28.9, plus the 28.9, and that is then 136.7 degrees. morning, grade 11s. This is then the last exercise now on trigonometry combined with bearings. Next week we'll write a class test and eventually an achievement test. Make sure that you understand here. So we have to look, is it a right angle triangle or not every time? So we have these P, Q, R, and S, the ferry points. A ferry is a ship which carries cars and stuff like that. And it sails from P, stopping at Q, R, and S before returning to P. There you've got the idea there. Now, the first place, the question is, show by calculation that angle QPR is equal to 55 degrees. So my first question is it a right angle triangle? Yes. Which function will I use here? And I can use tan. So tan P is equal to opposite over adjacent. Opposite over adjacent. To get the angle, it's second function tan. Remember that you will use brackets there, and my answer is then 55 degrees. First do the exercise, then you mark it. You will get that on the calculator. Number 2, write down the bearing of R from P. The bearing of R from P. Now the bearing of R from P is this one. R from P, north clockwise. I know now that this angle is 55 degrees. I know that this is a straight line. So what I need to find is this little angle first, and then I can add it to 98 degrees. So it's just 180 minus 98 minus 55, and that will give you R from P. Yeah, well, on the other hand, we can just subtract this 55 degrees also. Perhaps that's easier. And it is then 125 degrees, that bearing then there. Number B. Explain, so the bearing of S from R is 98 degrees. There you have it. And SP is 13.5. Explain why angle RPS is 27 degrees. So this is now the 180 degrees minus the 55 minus the 98 degrees, and that is how we get the 27. This is good enough for an explanation. You don't need to write more words or whatever. That is good enough here. And then they say angle PRS is 90 degrees. Calculate the distance RS. Calculate the distance RS. So this is a right angle triangle again that I'm using. I know that this angle is 27 degrees. Which function will I be using? Sine. So sine 27 degrees is then equal to RS over 13.5, which is the hypotenuse then there. And then which method? Top times, you will just multiply the two then there, and I got 6.13 meters. 6.13 meters. And then finally, find the total distance of that the ferry sails. That's right around PQRS. You just add all those sides, and it is 37.13 meters. That's then the total distance. Right, question 2. In the diagram, BCD is a straight line. It's a quadrilateral that you have there, and with all the information. Right. So in the first place, they say calculate BC. Again, is it a right angle triangle? Yes, it is a right angle triangle. So I can say, which function will I be using? Sine. So sine 30 degrees is equal to 15.7 over BC. Which method do we use now? Divide. 15.7 divide by sine 30, and that is 31.4 meters. 31.4 meters. Number B. Use the sine rule, so they tell you what to do, to calculate AEC. This is what we want to calculate now here. and show that. You may not start with that. A show that question means you have to get the answer then there. Using the sine rule will then be sine E over, which side is opposite this one? 15.7 is then sine 52 over 16.5. Then we cross multiply now here. You want the angle, so it will be second function, your answer that you get there, and we get then 48.57. Actually, you should first write the unrounded answer there. So 15.7 times sine 52 divide by 16.5 is equal to, and then second function, your answer. That calculator doesn't work like that. 15.7 times sine 52 divide by 16.5, and then second function sine, your answer is, so I got here 48.5734. Because it's a show that question, we have to put that step in, and it's then 48.57 degrees. Then it will round off like that. The next one is now number C1. Show that angle ECD is 40.6. Now ECD means this is the angle that we want to calculate now there. This is now not a right angle triangle in that case there. So show that the angle is 40.6 correct to one decimal place. Number C1. Right, so to get that angle then there, it is in a triangle, so it will then be 180 degrees minus this 48.57. It's just it's no calculation then there, minus the 52 degrees. And that's how we get what they gave you then, 79.53. Okay, and then we can say that in ACE, in this triangle now there, it is 180 minus 60 minus that 79.53. Remember they said it was a straight line, so that's why I just subtract them there, and we get 40.57, which rounds off to 40.6. So that's how we get that 40.6 there, just working with the triangles then there. Then number C2, now they want us to find DE. They want us to find DE. Let's look again at the sketch. So this is what we want to find now here, DE. And I use the cosine rule here. DE squared is then 16.5 squared plus 23.4 squared minus, in brackets, 2 times 16.5 times 23.4, and the angle that we are using is cosine 40.6 degrees, the one opposite the side. So DE is then equal to 233.5006. I get the square root of that, and the answer is 15.3. 15.3. And then the last question is now a question on the area. We're working there with the area there. Calculate number D, then calculate the area of the quadrilateral ABDE. That means you're going to have to calculate the area of each one then there. We first need that the length of AB to get that area there, because it's then half base height in that right angle triangle. This one is 27.19 meters, AB, and then I calculate the two areas. Then I calculate the two areas there to add it. So it is then, you'll have to add those areas. So it is a half of 27.19, because those two, they must be perpendicular. That's why I need AB, and the 15.7. This is in a right angle triangle. And then the second one is now not a right angle triangle. So it's a half BC, 15.7, times the 16.5 sine 79.46. Remember, two sides and the included angle. And then plus the third triangle, which is not a right angle triangle either. So it will be 16.5 times 23.4. And the included angle then there is sine 40.6. Make sure that you take two sides and the included angle every time. Then there. And the answer is then, for the first one, 213.4 plus 127.3271. I don't round off now. I round off in a final answer, 0.631, and then if you add the whole lot, it rounds off to 466 square meters. Right, very nice question then there. And let's look at the last one, number 3. There's my triangle. In the triangle, QPR is acute. We've got those sides, and the key